Today we are going to go over 7.2 Part 2 Integration by Parts. Last lesson we learned how do we integration by tabulus method. So everybody please spend 5 minutes to finish these two examples and compare with my answer keys. These are the answer keys for the two warm-up problems. Please have a look. Let me know if you have any questions. Let's go over some concepts. The first one, differentials. So differentials, we use d. For example, dx, dy, these are the differentials. How do we find the differentials? For example, d of e to the x give us e to the x dx. d ln of x give us the derivative of ln 1 over x dx. So generally speaking, d of a function, the differential of a function, we write it as df of x. This equals f prime dx. So d of u give us u prime dx. So this is how we find differentials. Now we are going to use the differentials to prove the integration by parts formula. So if u and v are functions of x and have continuous derivatives, in this case, when we take the differential of u and v, this will give us product rule du times v plus we keep u dv. Now we apply integral on both sides. So integration of duv give us is cancelled u times v equals, rewrite it, v du plus u dv. So now we are going to solve this part. So integration u dv equals uv minus integration v du. This is what we call integration by parts. So we change, based on this formula, we change integration u dv to integration v du. Sometimes when we switch this way, it will be much easier to solve. So let me copy this formula down. So u dv equals uv minus integration v du. So in order to use this formula, the most important thing we have to identify for any given function, what is our u, what is our dv. So on the left, what is our u, what is dv. There are some guidelines. Most of the case, we can use the rule. How do we choose u? So if you have logarithm function, inverse trig, algebraic function, trig functions, and exponential functions, following this order, we are going to choose u as one of these functions. For example, if you have ln of x, we are going to choose that as our u. So I'm going to show you how to solve example 1. So first step, we are going to choose our u equals ln of x. So dv will be dx. So this is the u, this is our dv. So from here, we are going to solve v equals x and one, two, three. Next, integration ln dx. So that's u equals u times v. So it's ln x times x minus integration v times du. So du here will be 1 over x dx. So this gives us x times ln x minus integration 1 times dx, which is x ln x minus x plus constant c. So this part is our du. Basically, integration u dv equals u times v minus integration v du. So after we define u and dv, we need to solve du and v. Let me show you another example. Integration arctangent of x dx. If you look at this function, we have arctangent based on the rule, Leit rule. there's an I between the late, basically. So arctangent is inverse trig function. That will be our u. So first step, u equals arctangent of x, and dv equals dx. So from here, du will be 1 over 1 plus x squared dx, and v equals x. So now the problem becomes integration. I will ignore the boundaries first. So arctangent of x dx will be u times v, which is x times arctangent of x, minus integration v times du, 1 over 1 plus x squared dx. This will be x arctangent of x minus, so this part we are going to use u substitution here. U will be 1 plus x squared, so du will be 2x dx. So after we define this, this will be 1 over 2 du over u. That's x arctangent of x minus 1/2 ln u, which is 1 plus x squared. Now we are going to put all the boundaries in. 1 to 2, 1, 2, 1, 2. So we can put all the boundaries in. So it's 2 times tangent inverse times tangent inverse of 2 minus 1 times tangent inverse 1, which is power 4, minus 1/2 times ln 5 minus ln 2. You can leave your answer like this. So everybody, I'll give you 4 minutes to finish these two problems, and you can compare your answer with mine. So these are the answer for these two problems. Please have a look. Now let's have a look at another example. So e to the x cosine of x dx. In this case, based on the rule, we have exponential functions and also we have cosine function. Cosine function is the trig function, and exponential function is here. So we are going to define our u as trig function because trig function is higher priority. So trig function cosine of x is our u. So dv will be whatever is left, e to the x dx. So from here, du equals negative sine of x dx, and v equals e to the x. So the original problem, e to the x cosine of x dx, will be u times v cosine of x times e to the x minus integration v du e to the x times negative sine of x dx. Give us cosine of x e to the x plus e to the x sine of x dx. Now it becomes similar to before. We have to use integration by parts again. So from here, u equals sine of x, dv equals e to the x dx. So du will be cosine of x dx, v will be e to the x itself. So this becomes cosine of x e to the x plus u times v e to the x times sine of x minus v du e to the x du, which is cosine of x dx. So the left side is this, the right side we also have this. We are going to move this term to the left. So it's twice e to the x cosine of x dx equals e to the x sine of x plus cosine of x. So our final answer, e to the x over 2 times sine of x plus cosine of x plus constant c. Okay, everybody, you can work on this problem yourself and compare your answers with mine.